Chintan has joined or not? Not yet.
No, she hasn't.
Fine. Close again. Fine. Just give me a while. I'll just revise the concept for you within a minute. So I have explained about the electrophilic substitution and nucleophilic substitution on the haloarenes, right?
Yes,
Yeah. So this is a benzene ring, and here would be your halogen, correct? Yeah.
Yeah.
Halogen is a electronegative. Keep it in your mind. Okay. And these electrons are delocalized on the benzene ring. And because of that, what happened? It is utilized to form a double bond in between halogen and the carbon of benzene. And the electrons on the benzene ring would be delocalized at the respective positions ortho, para, and ortho. So
there is a resonance structures form.
Yes. Canonical forms would be there, and mostly electrophilic attack would be possible at the ortho and the para position. Meta position are the electron deficient, because whenever substituent, only single substituent halogen is present onto the benzene, it would be ortho para directing. This substituent is what? Ortho para directing. Okay. And one more thing which you have to keep it in your mind about it, like among this ortho and para position, para product or whatever product you will get, para product would be major product. So the reason behind it, para product has
because
a
symmetric.
Yes, because it is symmetric. Because if you suppose I have written here, suppose one of the product here, I have added one more halogen, dihalogenation I have done. So it is a symmetric molecule. I can cut it into the two halves, right? Easy.
Yeah.
And because of that, it is difficult to break down. Even the melting point and boiling point of such a symmetric compound would be more as compared to your ortho product. Clear? And
yeah,
even I explained about the hydrogen bonding as well, right? Yesterday.
Yes.
Yeah. But then sometimes what happens, if hydrogen bonding is involved in the product, that time it make that molecule is more stable. And hence that time also it can be form a major product, because if stability of compound is increases, majority is also increases, or amount of formation of that particular compound is also increased. We may say yield is increased for that particular compound. Okay. For example, I'll let you know what. Suppose this is a benzene. Okay. Here is your hydroxyl group, OH, means it's a phenol. Okay. And at the ortho position, there would be the nitrogen with double bond O and O minus, correct? And this hydrogen and oxygen can form the hydrogen bonding in between, right? Yes or no?
Yeah, we have learned about it last year in chemical bonding.
Yeah. So in this, what happened? Because of this hydrogen bond, your molecule become more stable. And because of this stability, what happened? Yield of this particular compound would be increased. Clear? This hydrogen bond can be happen with any of the electronegative atom present into the adjacent group. It can be happen with oxygen. Even it can be happen with nitrogen. But then at a time only one. Both cannot be possible. Okay?
Yeah.
Yeah. So in nucleophilic substitution, I have explained what? Nucleophilic substitution is highly impossible actually with respect to your halogen compounds, right? Yes or no? Why?
Yes.
Your halogen compounds are also electronegative, right? Means if you have to substitute.
And the nucleophile will also be electronegative.
Yeah.
So.
And nucleophile is also electronegative. And your ortho para positions are also electronegative due to the lone pair utilized in the delocalization, isn't it? And because of
Yeah.
that, like will be repel each other. It's a magnetic rule actually, but then same for we apply for the same charges, isn't it? And because of that, what
Yeah.
this is highly impossible. But then if you pressurize it, if
So it would form at meta, like if the in special conditions, it will form at meta position because it's electron deficient.
yeah, it may form at the meta position, but then apart from that, ortho para possible, but then that would be in a drastic condition, means you have to increase a lot of temperature, you have to put more pressure. It's like a we can correlate with the arranged marriage. It's like suppose somebody don't want to get married, but then like due to the family pressure and all, when certain conditions are made because of this and that to be done. So in that situation, anyhow, though mind is not there, then to people get married, isn't it? In the same way, same situation
Yeah.
happen in between this halobenzene and the nucleophile. So nucleophilic substitution is nothing but arranged marriage without permission. Okay, in a drastic
Yeah.
condition. So those conditions would be what I'll let you know. Fine. Already I have explained. I think you have gone through.
Yes, ma'am.
Yeah.
Like
So I
we've
won't.
completed this chapter like twice, like
Yes,
this
yes.
year and last year as well.
Yeah, yeah. Fine. So I'm not gonna go much deeper. I'll just explain you what happened exactly, what conditions we need to be add in this. Okay, just give me a while.
Yeah, ma'am.
You have to use a temperature to do this. Okay. So what would be the temperature? I'll let you know. I think 600 something more than that. Yeah. Yeah. You have to use a nucleophile. Suppose you are going to use a nucleophile NaOH in this condition. Okay. And this will be the aqueous NaOH. Aqueous NaOH is a nucleophilic NaOH, right? And if you use alcoholic NaOH, that would be the basic one. Okay. So difference also already I have explained about the basic NaOH and the aqueous NaOH. Okay.
Yeah,
Now here
ma'am.
the temperature condition is what? 623 Kelvin temperature you have to introduce. And with the same time, you have to increase the pressure at 300 atmosphere. Okay. And later you have to do the protonation by adding the H plus ions in that. You will get this one, benzene ring with OH. Means OH act as a nucleophile and it replaces your
Halogen.
halogen. Fine. But then this nucleophilic substitution would be more effective if any electron withdrawing group would be present on this benzene, halobenzene. Okay. In that what? Nitro group, we know that it's a electron withdrawing,
So
correct?
more the nitro groups, less the temperature and
Rate of
pressure
reaction would
required.
be faster. Clear? Suppose here would be the nitro group. Here would be the nitro group. Dinitro group would be there. That time you require a less pressure and the less temperature. Correct? NaOH 368 Kelvin. If you add the proton, if you do the protonation for this, you will get the product. Only what? Chlorine will be replaced with OH. Nitro group would be as it is. And trinitro group, if 3 nitrogen groups would be present over here, that time you need not to heat it as well. You just have to warm up. Okay, you will get the
Yeah.
product easily. So as
So
number of
more the electron withdrawing groups are there,
withdrawing,
less the temperature and pressure required.
yes, and it will be favor more nucleophilic substitution on the halobenzene. Clear?
Yeah, ma'am.
Fine. Shall I erase it?
Yes, ma'am.
Fine. Now see the next one. We have seen about the electrophilic substitution. Electrophilic substitution is very easy on the halobenzene because as we know that here already we have discussed about this is your chlorine, right? And this positions ortho, para, and ortho. These are the electronegative. So whenever this double bond would be attacked onto the electrophile, suppose this is electrophile, electrophile would be shown by E plus. Okay. So whenever it will be attacked over here, what happened? Easily bond would be formed. Here it will come electrophile, okay, with hydrogen. Yeah.
Yeah.
And this is your Cl. Right? Is it- Sorry, what happened?
Nothing, ma'am.
I'm getting background noise, I guess.
Actually, I'm traveling right now, so yeah,
Oh,
there's a little bit of noise.
I do understand. It's okay, fine. As double bond is utilized to form a bond with electrophile, what happened? It generate a positive charge over here at the chlorine, right? Yes? Yeah.
One of the double bond is broken because
Yes.
like the electrophile takes the electron.
Yes. And here what happened? This step is a rate determining step, RDS, means slow step, right? This happened in a slow
Yeah.
manner. It determined the rate. Okay. And hydrogen would be lose its electron to form a double bond or to satisfy this positive charge. And this step is a fast step. Okay. And this is called as aromatization. You will get what? This one. Your
Yeah, we learned about it in hydrocarbons.
yes, electrophile, and this would be your chlorine. Clear?
Yes, ma'am.
Understood? Fine. So this would be what? Fine. Here we have learned about what this electrophile. This electrophile can be anything. It can be chlorine or any halogen, right? It can be sulfonate group SO3H, right? It can be any alkyl group, CH3Cl, alkyl halides you can use. Then acyl group also can be used, CH3 or R, C double bond O, Cl, isn't it? So
Yes.
these all things can be used as an electrophile in this reaction, electrophilic substitution reaction. So one by one, all we are going to see. Shall we start?
Yes, ma'am.
Yeah. So in the first, we are going to see the reaction of halobenzene with this halogen. Suppose this is a chlorobenzene and you have to make a dichloro derivative of it. So what you're going to do? What would be the situation? If you have gone through the video already, I have explained it. I hope you're aware of.
We'll use zinc, Zn
We have to
Steel 2,
use
right?
here anhydrous FeCl3. What it will be? It's a Lewis
Anhydrous acid.
acid.
It is a Lewis acid.
Yeah, Lewis acid catalyst, right? So what it
Yeah.
does, FeCl3 react with the Cl. It will be produced FeCl4, correct? This will be the Cl2. It won't be single Cl. Okay.
Yeah. I will get a
FeCl4
Cl free
and
radical.
Cl. This will be electronegative. This will be electropositive. So this Cl become electron deficient due to use of this Lewis acid. And because of that only, we should use Lewis acid for the halogenation reaction. Okay, on the benzene. Clear? Now what happened?
Yeah. So there
This,
is a Cl free radical form which is like electron deficient. It goes and attacks on the benzene ring.
no, actually what we know that chlorine is electron rich. It's electronegative, correct?
Yeah.
So electronegative compound or element cannot be go closer to the benzene because benzene itself is electron rich.
So it will attack on the para position to
Yes.
form a
To
symmetric
make it,
benzene.
yeah, to make attack of benzene on the chlorine, we should make the chlorine electron deficient, right? And it will be done with the help of this Lewis acid catalyst. Okay,
Yeah.
fine. Yeah. Now what happened? This benzene would be attacked on the Cl and this bond would break. Okay. And what you will get?
A dichlorobenzene.
Yeah, you will get a dichlorobenzene. But then attack can be possible by this double bond or even can be this double bond. Okay. Fine. So whenever it will be happen with this double bond, that time your product would be this. Clear? This is your chloro, right? Sorry, this is your chlorine. Here it is hydrogen with a positive charge generated over here. Or this is your path A. Okay. And by the path A, you'll get the intermediate in this manner. And by the path B, you will get the intermediate how? I'll let you know. So in this time, at this time, what happened? This double bond would be as it is. This double bond would be as it is. That double bond does not touch at all. Okay. What happened? This double bond is utilized. So your chlorine would come over here, right? Hydrogen is present over here, and as the double bond is lost in between these two carbon, electron would be withdrawn and it become a electropositive in nature. Correct?
So product B is the major product because it's symmetric and more stable.
Yes. So here two products are possible. This hydrogen would be lost. Here also this hydrogen would be lost. You will get the product over here. What? Ortho dichlorobenzene. Correct?
Orthodichlorobenzene, and we'll get paradichlorobenzene.
Yes. Very good. Here you will get. Here you will get what? Paradichlorobenzene. Cl and the Cl. Clear? This would be major and this would be minor. Right? Because it is symmetric.
Due to symmetry.
Fine. Got it?
Yeah.
Fine. So same steps you have to follow for rest all reaction, electrophilic substitution reaction. I'll let you know.
Once can you just teach about the process of acylation, like acyl groups?
Yeah, sure. I'll go for it. Fine. Now, Friedel-Crafts acylation and the alkylation. These all things also can be happen with the help of Lewis acid catalyst only.
Alkylation is fine. Acylation, I'm confused between like whether O will be attached, O group, or like the Cl will be attached.
Okay. I'll let you know. Suppose this would be your halobenzene, correct? Here it is chlorine, fine. And if it will be treated with this CH3, C double bond O, Cl, what it will be? Fluoroacetate?
Yeah.
You are going to react it in the presence of Lewis acid catalyst. Okay, as I am used here Cl, I want in catalyst also Cl. Okay.
So will you use FeCl again?
Yeah, FeCl3 you can use, or you can use AlCl3. Both can be possible. Okay, Lewis acid catalyst, which acid you can use? FeCl3 or AlCl3. Okay. Among these, any one you can use. Fine. Now, anhydrous is very essential. What do you mean by anhydrous?
No hydrogen, like water molecules in that, or
yes,
dry.
Yes. It will be complete dry, and there should not be any sort of like moisture or water present in this reaction, right? So AlCl3, if I have used, AlCl3 also means act in the same manner. Okay, it will take this Cl, it will form AlCl4, and because of this, your carbonyl group is there, na, C double bond O. It will become electropositive. Understand? I'll show you how.
Yeah, it will become an electrophile.
Yes, CH3, C double bond O, Cl plus AlCl3. What it will be formed? CH3, C double bond O, here AlCl4. Correct? So it become electron positive and it become electron negative. Clear? And on this, your benzene ring would be attacked. Right? This is Cl. Correct? It will go either at your ortho position or at the para position. So whenever it will be attack on the ortho position, I'll take this side bond, so that will be easy to understand. You need an alternate double bond only, right?
Yeah.
1, 2, and 3. So when I use this bond, it will attack on the carbonyl group, correct? Right?
Yes.
This will become and revert completely again double bond, and this will be break. Clear? It happen at the ortho position. And if I have to do the attack with the para position, this double bond I will utilize in a same way, mechanism in same way. Carbon-carbon double bond would form again, and AlCl4 would be detached. Correct? Understood? Means the new bond form in between what? Your ortho position and your C double bond O. This part would be break completely, and only this part would be attached to your benzene. Clear?
Yes,
so you get over here two products. First product would be what? This is your halobenzene, Cl, right? At ortho position, there would be C double bond O, and here it is CH3. Here it means like this would be the product. Intermediate would form by the positive charge, and that would be neutralized by the loss of hydrogen. I need not to show that, right?
Yeah.
If you want, I can show. That won't be a problem for me.
No,
Just
I
I
was just confused between like the Cl and O, like which one would be attached to the benzene ring, like.
no C double bond O. Carbon only would attach, but then carbon with the carbonyl group would be attached to the benzene. Okay.
Yeah.
Okay. And another product would be what?
It will be at para position.
Para position. Yes. Cl. Your C double bond O. CH3. Right. This would be the
So yeah.
and this
Again,
would be
para would be the major one, and ortho would be the minor.
yes. And this is called as what? Friedel-Crafts acylation. Okay. This is called as Friedel-Crafts acylation. I hope you understand clearly.
Yeah, ma'am, got it.
Need to explain alkylation now?
No, ma'am, alkylation I'm fine with that. Only like acylation, I was confused between the like which one would be attached.
Okay, fine. Now the next point which I actually wanted to explain you, reaction with the metals. Okay. Reaction of haloarenes with metals. Fine. In the C, this would be what? Your haloarene X. Okay. If it is treated with the sodium and the haloalkane Rx, in that time, what happened in the presence of dry ether?
Yeah, Wood's reaction.
Yeah, actually, it's not a Roots reaction, it's a Roots fitting reaction. Roots reaction, I have explained you what in the sense. 2 moles of Rx treated with sodium in presence of dry ether. Correct? You will get like these two R group or alkyl group will be coupled with each other to form the product in this manner. Correct? Isn't it? You will get 2 moles of NaX. And this reaction is what? Roots reaction. Yeah. In this,
and the other one is Wood's fitting reaction.
Alkyl halide, yes, it is aryl halide, sorry. Aryl halide treated with alkyl halide.
So we get alkyl aryl.
No, actually in this case, what happens? Sodium will take this halogen as well as this halogen in the same manner, but then coupling will happen into the aromatic ring and the aliphatic alkyl group. Understanding? Means, yeah. Friedel-Crafts alkylation, whatever product you got, in same way you will get the product in in this case as well. So you will get aromatic ring attached to your R group, alkyl group. Okay, the plus 2NaX. Right? And this reaction is called as what?
Wood's fitting reaction.
Yes. Roots fitting reaction. Clear?
Yes.
Yeah. So this thing you need to keep it in your mind. Shall I erase it?
Yeah, ma'am.
Now see the next one. Instead of first of all, we have to take what? 2 alkyl groups for the Roots reaction. Now 1 alkyl group and 1 aryl group we took, right? Aryl haloarene and haloalkane. Now I'm going to take 2 haloarenes. Right? What will be happen in this case?
We'll have like diphenyl groups.
Very good. In this case, you will get a diphenyl group, right? Means coupling in between 2 aromatic ring would be possible in this case. Isn't it? Yeah. It will get coupled with each other. This is what? Diphenyl. Right?
Yeah.
Right? Plus 2NaX. And this is called as only fitting reaction. Okay. Whenever only alkyl group, keep it in your mind. Whenever only alkyl group, two alkyl groups
That's
to form
words.
major, major alkane, right? That is what Roots
Yeah.
reaction.
When there is a
Yeah,
aromatic group and a
one
alkyl group.
alkyl halide and one aryl halide. That would be coupling in between these two will be
Root
root
splitting
splitting.
reaction.
Hmm.
And
And
when
when
there's
both
only
are aryl
aryl,
group,
yeah, we have only fitting reaction.
yes, that would be just fitting reaction. Okay, clear?
Yeah.
Any query in your mind about it? Please let me know.
No, I got it.
Okay. So in this case, we have almost complete the chapter. Hardly few things are remain that I'll explain you. They have given us a polyhalogen compounds. Okay. In that first dichloromethane. Right. That is also called as what? Methylene chloride, correct?
Yeah.
What would be the structure for dichloromethane? This is your methane group, right? From methane, if you remove two hydrogen and replace it with the two chlorine, you will get what?
Cl2CH2.
Yes, CH2Cl2, correct?
Yeah.
That will be what? CH2Cl2. This is dichloromethane. About it, what has been given? Dichloromethane is widely used as a solvent, as a paint remover. Where we use?
As a paint remover.
Yes, as a propellant in the aerosols and as a process solvent in the manufacture of drugs. It is also used as a metal cleaning and the finishing solvent. Methylene chloride harms the human central nervous system. Exposure of the lower levels of methylene chloride in air can lead a slightly impaired hurting and the vision. So we cannot expose to our nervous system. It will be badly affect on our nervous system. Okay. Higher levels of methylene chloride in air cause the dizziness, nausea, then after that numbness, then the numbness in the fingers and toes. Then the inhuman direct skin contact with the methylene dichloride causes the intense burning and mild redness of the skin. Direct contact with the eyes can burn the cornea. So it is really very dangerous chemical. Fine. Dichloromethane. Understood? Hello?
Yeah.
Yes, ma'am.
Fine. See the next chemical which is given to us, trichloromethane. Trichloromethane means what you have to do in this? CHCl3 means three hydrogen from the methane should be replaced with chlorine, correct? Yes or no?
Yeah.
Yeah. Then in this case, what has been, my background now noise is not disturbing you, na? If it is so,
No, ma'am.
chemically, this CHCl3 is nothing but what? Chloroform.
It is
Understand?
also used as anesthesia.
Yes, it is used as anesthesia, right? Yes or no? So
Yeah.
chloroform is employed as a solvent for the fats, alkaloids, iodine, and other substances. The major use of chloroform today is in the production of Freon's refrigerant R22. It was once used as a general anesthetic in the surgery, but has been replaced by the less toxic, safer anesthetics such as ether. Okay, earlier it was used as an anesthetic, but then now it is instead of ether is used. And as might be expected from the use as a inhaling chloroform vapors depresses the central nervous system. Breathing about 900 parts of chloroform per million parts of air. Okay, it will attack on your nervous system. It will give you fatigue and headache. Then the chronic chloroform exposure may cause the damage to the liver and to the kidneys. And some people develop the sore when the skin is immersed into the chloroform. Chloroform is slowly oxidized by the air in the presence of light to extremely poisonous gas. And gas that is a carbonyl chloride. That is also known as the phosgene, this one. Okay, how it will be formed? When chloroform, CHCl3, exposed to the oxygen, it undergo oxidize. Okay,
In the
oxidation.
presence of sunlight.
Yeah, in the presence of light, you will get this. Okay, and the name of this poisonous gas is phosgene. Please keep this formula in your mind, maybe a chemical formula or maybe reaction they may ask in future. Okay, fine. Now, next chemical which is given to you, that would be tetrachloromethane, CCl4.
CCl4.
Yeah. So in this what? It is a product in large quantity used in the manufacture of refrigerant and the propellant for the aerosol cans. It is also used free stock in the synthesis of the chlorofluorocarbons. Chlorofluorocarbons? Huh? Do you know fluorocarbon, where we use it?
Refrigerators, most commonly.
Refrigerator and ACs, right?
Yeah.
Other chemical, pharmaceutical manufacturing and the general solvent use, we can use the CCl4. Until the mid 1960s, it was also widely used as a cleaning fluid, both in industry as a degreasing agent, and in the home as a spot remover and the fire extinguisher. There is some evidence that exposure of the carbon tetrachloride causes liver cancer in humans. And most common effects are dizziness, light headedness, then the nausea, vomiting, which can cause the permanent damage to the nerve cells. In the severe cases, these effects can lead rapidly to the stupor, coma, then the unconsciousness or death. Okay. Then another one is given, that is freons. Another chemical they have given, that would be freons. Just give me a while. Huh?
Yes.
Hello?
Yes, ma'am.
Yeah. That will be what? Freon. See. About it, what's given? Schwarz reaction we have seen, right?
Yeah.
This freon is related to the Schwarz reaction. The chlorofluorocarbon compound of methane and ethane are collectively known as freon. What does mean that freon? Chlorofluorocarbon compounds of methane and ethane. Okay, methane and ethane collectively is called as freons. They are extremely stable, unreactive, non-toxic, non-corrosive, and easily liquefiable gases. Freon 12. Freon 12, what is the formula for that? It will be CCl2F2. Is one of the tetrachloromethane by Schwarz reaction. How it's been formed? By the Schwarz reaction. What is the formula? CCl2F2. Okay. These are usually produced for the aerosol, propellants, refrigerant, air conditioning purpose. By the 1974, total freon production in the world was about 2 billion pounds annually. Most freon, even that used in a refrigeration, eventually make its way into the atmosphere, where it diffuses unchanged into the a stratosphere, and in a stratosphere, freon is able to initiate the radical chain reaction that can be upset the natural ozone balance. Understanding? And because of that,
Yeah.
this chlorofluorocarbon is very bad for the ozone layer present into the stratosphere. You might have learned it in your grade 8 onwards. 8, 9, 10th, 11th, 12th, right? Since last 4 years, you're learning this. Ozone layer deflection.
Yeah.
Clear?
Yeah,
What is
got
the
it, ma'am.
term for this? Chlorofluorocarbon
Carbons.
compounds of methane and ethane. Fine. Next.
Yeah.
I think it will be the last one. Para. Dichlorophenyl trichloroethane. Sorry. Dichlorophenyl trichloroethane. This is the name, and commonly it is called as DDT.
DDT.
Okay. Dichlorophenyl trichloromethane. Sorry, ethane, DDT. DDT is the first chlorinated organic insecticide. Was originally prepared in the 1873, but it was not until 1939 that Paul Mueller of pharmaceuticians and the Switzerland discovered the effectiveness of DDT as an insecticide. Paul Mueller was awarded the Nobel Prize in the Medicine and the Psychology in 1948 for this discovery. The use of DDT increased enormously worldwide basis after World War II, primarily because of the effectiveness against the mosquito that spread malaria and lice that carry typhus. However, problem related to the extensive use of DDT began to appear the late 1940s. Many species of the insect developed resistance to DDT, and it was also discovered to have a high toxicity towards the fish. And hence, there would be the limitation for the use of DDT. What is the structure of DDT? That is essential. You should learn it. The structure include one phenyl ring. Phenyl ring is nothing but a benzene ring. Okay. Without one hydrogen, which is attached to carbon. This will be the carbon. This side, it will be the hydrogen. Here, nothing is means what? Carbon is present. Okay. Do not forget.
Yeah.
Here also one carbon, and there would be 3 chlorines on that carbon. Another phenyl ring, chlorinated phenyl ring, would be attached over here. Fine. So that this is nothing but a carbon compound which has 2 phenyl ring. Okay. Another one carbon is replaced with all the chlorines, and only one hydrogen will be present in that. This will be DDT, dichlorophenyl. These are
Ethane.
dichlorophenyl trichloroethane. This is trichloro, and 2 carbons are there, and hence its name is ethane. Okay, so this would be your parent. This is what? Ethane, 2 carbon. Trichloroethane.
Yeah.
Trichlorophenyl. Okay, dichlorophenyl trichloroethane. This would be the name for this compound, DDT. Clear?
Yeah,
This was
ma'am.
the last point of your chapter, and your chapter has been finished. Tomorrow, I'm going to post questions regarding this. Today itself, I'll post. So entire day you can utilize for it.
Okay.
Right?
Yeah, ma'am.
Yeah.
Now,
So
what's the
shall I?
next chapter we are going to start?
Electrochemistry you asked for, huh?
Ma'am, actually, my exam is done. So, like, we got it revised in the class, so we can start another chapter.
Whichever you say.
Okay, ma'am.
Text me regarding.
Sure, ma'am. I'll just see my
Okay.
schedule and I'll text you.
Shall I go with any physical chapter? Because this is
Yeah, ma'am.
organic first chapter which we have done. will start any of the physical chapter. Most probably I'll start with thermodynamics then.
Yeah, ma'am, that's fine.
Okay.
Yeah, ma'am.
Shall I end the class?
Yeah, ma'am. Thank you. Good night.
Take care, beta.